the camera going now. All right, so yeah. So we're going to do fractions to a decimal and decimals to fractions, right? Because as you guys probably realize, some of those questions, especially when it comes into hours, I wouldn't be saying, okay, I worked 2 3/4 hours or something like that. I certainly wouldn't write it as a fraction. It's a lot easier to do it as decimals, right? And it's a lot quicker that way. So let me try one nice and easy first. So converting a fraction to a decimal, right? So something like 1/4 as a fraction. To turn that into a decimal, think back to when we had that big, where was it? Screw it, I'm going to mess myself up if I try and explain it that way. Essentially, turning a fraction into a decimal, we are just taking this and dividing it by this. Numerator divided by the denominator. So if you even want to look at it like this, 1 divided by 4. Now you can long division that, right? Where you'd be doing something like this. 1 divided by 4, right? We can't do that, right? So that's where we'd throw in these little decimals, and then we'd have to start pulling in the extra numbers. And I'll usually do this to let myself know that these are now the extra numbers. Now 4 goes into 10 2 times, right? 2 times 4 is 8. 10 minus 8 is 2, right? I'm going to bring down another little number, right? I got to create a 0 and bring it down. 4 goes into 20 5 times. 5 times 4 is 20. We're left with 0. So that's our fraction, or I mean our decimal, right? So 1/4 is 0.25. Does that make sense? Think about our dollar.
Yes.
Yeah, our dollars and our quarters, that's essentially what it is. All right, same thing if I said, and we're just running through those easy ones, right? 1/2 is the same as saying 1 divided by 2. And again, just for the sake of clarification, we'll run that through, right? 1 divided by 2. We can't do that, so now we're going to have to make up some numbers, right? 2 goes into 10 5 times. 5 times 2 is 10, right? So half equals 0.5. How are you guys doing?
Good.
Making sense?
Yes.
Yep.
All right. It's the same thing. Let's try the 3/4. Okay. So 3/4 reads, and I'm just going to go right into this. All right. 3 divided by 4. Again, 4 can't go into 3. So now I've got to create some numbers. 4 goes in to 30. How many times?
6.
Is it 6?
7.
Yep.
Yeah, 7.
Yeah. Right? And 7 times 4?
28.
Yeah, we got our 28. 7 times 4 is our 28. Right? So again, we'll do our borrowing. 10 minus 8 is our 2. Right? So again, I got to create a number and bring it down. 4 goes into 20. Oops, sorry, the light's hitting that pencil a little funny. 4 goes into 20 5 times. 5 times 4, 20, 0. So 3/4 is 0.75, right? Or again, like 3/4 is 75 cents. 2/4 is 50 cents. 1/4 is 25 cents. Right? So far, so good?
Yep.
I'm going to write these ones down for you. You guys try them for a sec. Try 5/8 and try, let's try this one. Try 11/16. Okay. I'm going to give you a second to do that. Don't worry if you didn't get there yet. Right. Again, normally I'm using my calculator to do this all fast, but we'll do this with the long division. Might as well get into the practice. So again, with 5/8, remember, numerator divided by the denominator, right? So, or we can write it like this. 8 doesn't go into 5, right? So again, we're going to throw up that 0, put down that decimal, because we have to start making up numbers. So now, 8 goes into 50. How many times?
6.
Yep. 6 times, right?
48.
Yeah, 6 times 8 is 48. Oops, I'm going to write it with this one. So 48. So again, if we do our subtracting long, we need to borrow, right? And we're left with that 2. I need to create another number, bring it down. 8 goes into 20. How many times?
2 times.
2 times. Right? 8 and 8 is 16. And just doing everything long for the sake of it. 10 minus 6 is 4. I'm going to create another one, bring it down. All right? 8 goes into 40 5 times, and we get 40. 0. Right? So this 5/8 as a decimal is 0.625. All right? I'm going to come back to this one eventually when we do the converting back to fractions. So I want to show you something for a sec. But this one over here, right? By the way, did anybody get that?
Yeah.
Okay.
Yep.
All right. So 16 again does not go into 11. Put the decimal because we got to create numbers, right? 16 goes into 110 6 times. Did anybody else get that?
Yep.
Okay. And 6 times 16 equals 96. All right. Again, for the sake, that's 0, 10. We'll bring that over. And that makes it 10. 10 minus 6 is 4. 10 minus 9 is 1. All right. And creating another little number. All right. 140 divided by 16. Whoops.
8.
16, yep. 8 fulls. But 8 times 16 gives us 128. All right. 8 can't get through there. So we'll make that a 3. 10 minus 8 is 2. 3 minus 2 is 1. Right? Yeah, not quite there yet. I'm going to bring that baby down. And 120 divided by 16, we get 7 fulls.
Yep.
Right? 7 times 16 gives us 112. Right? And again, normally that we would probably be using calculators to do this fast on a job. Right. I think this one might go on for a little while.
No, that's it.
Is this the last one? Oh yeah, shit. I mean, shoot. Damn it, it's recording.
I heard shoot.
That's it. Good. Your check's in the mail. There we go. Right? So again, that's it in a fraction. Or I mean in a decimal. Ooh, that's an ending in a 5 as well. When we start doing the decimals back to fractions, the reason I have these starred is I want to show you something when it comes to a decimal ending in 5. But I'll wait till we get to the decimals to fractions. But do you guys get that?
Yeah.
Essentially, to turn a fraction into a decimal, you're just turning it into a division, right? 5 divided by 8 or 11 divided by 16, right? 1 divided by 2 or 3 divided by 4. And again, you could type that into your calculator right fast and you'll end up with these numbers as well. Did anybody try that just to check?
No, I didn't.
Yeah, because if you did that with your calculator right away, 11 divided by 16, 0.6875. 5. Right? Remember, 5 divided by 8, I get my 0.625. All right? Again, I did 3 divided by 4, you get that 0.75. We just did it out the long division way, just for the simple fact of practicing that out.
Yeah.
Okay?
So from a decimal and then turn that into a fraction, that's where my problem is. I don't have a clue.
Beautiful. All right. I'm going to turn the page and we'll do that then. All right. So I could start you off with something like, let's go with just 25. Sorry. We had the 1/4 to start off before. Let's take it from that decimal. Okay, so if we saw 0.25. Now, most of the time, people know already that 0.25 is a quarter. Because again...
This is decimal to fraction, Terry?
Pardon me, hon?
This is decimal
Yeah,
to
decimal.
fraction?
Yes, sorry, yep. This time we're going to go decimal to fraction. Okay. And I'll say that this one was fraction. And I'm recording, right? Yep.
Yep.
Fraction to decimal. Okay. See the lights on there. Maybe I gotta dim that down a bit. There we go. Alright, so this time we're going from a decimal into a fraction. Essentially, going from a decimal into a fraction, right, if we didn't already know that 0.25 was a quarter, the way that you would write this is behind the decimal point, I have 2 decimal places, right? And remember, okay, you get what I was going to get at now?
I got, yeah.
All right, right? So these are now, this is ones, tens, hundreds, but after the decimal we go tenths, right? Remember that TH attached to it? Hundredths. So we've got 2, so we have 2 places, or hundredths. So essentially this is like going 25 over,
100.
you got it.
See, when I'm in class, this one I'm lost.
Ah.
I don't know how to convert that into and then I fall behind.
Oh, there we go. Yeah. So once you have it like this, it's just a matter of pulling it down to into that lower one again, eh?
Yeah.
Right? And so what can we change this down? Or what would be the lowest common denominator here?
4.
Right? Or, sorry, I know where you're getting at, but 25.
25, yeah.
Yeah, because 25 can go into itself one time, but it can go into 100 or $1 4 times. Right? And that's our lowest common. Right? Same that is if and we'll just stick to the ones that we were sort of playing with at first. If I went 0.75, again, it's like 75 over 100, right? Because I've got 2 numbers or 2 places, so I add 2 of those zeros. Again, 25 can go into 75, right?
Yeah.
It can go in 3 times.
So each placement, each how would you pronounce it? Each tenth or th
Yep.
is the zero you're adding to the bottom denominator?
Yes. Yes. Exactly.
So it
So
has to be after the decimal.
yes. So here, try this one out. Keeping in mind what you just said to me.
I'm just dealing with a cold right now. So
Oh, no worries.
sorry, sounds.
So now take a look at this one. I've got 3 places. So what do you think this one's going to be written as now?
1,000.
Yes. 125 over, and I need 3 zeros because I've got 3 numbers after the decimal. 1, 2, 3. All right. Now, is there a number that can go into both of those?
100.
100? Did someone, I heard something else?
5.
5? Yeah.
Yeah, but
Yep. There's a few different ways. It would just, take a little longer. But 5 would probably get us there the best, right? Because what's 125 divided by 5? How many times can 5 go into 25? Or 125? 5 times?
Yep.
And what does that leave us with? Oh, whoops, sorry, my bad. Yep. I'm sorry, my brain went somewhere. And then how many times does 5 go into 1,000? Oh no, sorry, I chose the 25.
Yeah, we chose the 20.
Yeah, that's where I was kind of like, wait a minute, what's going on? 25 is what I chose.
You're trying to go 5 into 125 or 5 into 25?
Boop-a-da-doo. I went 125 divided by 25. Like, meaning 25 was the one I chose.
Yep.
Yeah.
Yeah.
Do you guys get that?
And then 25 into 1,000.
Yeah. So how many times does 25 go into 1,000?
40. 40, yeah, it's correct.
40. Okay.
You can factor it down to lower.
Yes. Right? Because 5 can go into 40, can't it?
Yeah.
Right?
1,
Yeah. So if 5 can go into 40,
8.
exactly. It goes into itself once and it goes into 40 8 times. Right, here, let me do this in here. I chose 25 and I chose 25. Does that make sense?
Yep.
Cool. All right. Let me try one here. Convert the following. Now, I don't know what the answer to this one's going to be. Oh, Here, let me try one with a whole number with you. So if I've got something like this, I've got 6.75. Right, I got a whole number and a decimal. So turning this into a fraction, this is actually going to end up being a mixed fraction. Do you understand that? Because this is a whole. Anything after the decimal is a fraction of a whole. All right? Am I losing anybody yet? So that's my whole. So I'm going to be 6 is the whole. And now I got to figure out the 0.75. We actually did that up there already. Right? So 6.75 means 6 3/4. And if I was to do this, this is a decimal inch. Right? And this is what Gary was doing with some of those questions we were taking up. It is a little bit quicker and easier when you're kind of trying to do math really fast, when you're trying to do your estimatings and stuff like that. I usually throw things back into decimals because it's easier on a calculator, unless you got the construction masters where you can actually use fractions. But we can't type in fractions on here. I don't have anything. But if I can pull a fraction down into a decimal, now I can actually put that into a calculator, right? If I was trying to add some of those ones that we were doing, like, well, yeah, any of our homework stuff, right? We could actually pull it into our decimals instead of trying to do all this fraction stuff. Right? Is that making sense for anybody?
Yep, it makes perfect sense.
Okay. Right? Because, again, if I was trying to add, say, 1 3/4 plus, you know, a half, I can't do that in my calculator the way that we had fractions written out. But I can pull down, what did I say, 1 3/4? Right, so 1 3/4, I said plus 1/2. Sure, I could do all the stuff that we were just playing around with, but if I pulled this down into decimals, right, so this one here would be 1. Yep, 1.75 plus.
Yep. 0.5.
Oh yeah, we didn't do the point, yeah, but the 0.5. And I can actually set it up like this and add those together. 5, 7, what do we end up with our 12? Throw that up there. We got our
2.25.
Right?
Yeah.
And then we can throw that back into a fraction, which ends up being 2 wholes and a quarter. Right? I can read that on a tape measure. 2 and 1/4. Right? It's hard to find 2.25 on this tape measure. Right? But I can find 2 and 1/4. Right? Because do you see these ones right here? Those longer ones, 1, 2, 3, 4. Right? Or if I throw these guys up here. Is this making sense?
Yep.
Yep.
Cool. Because this is the faster way to go. So that being said, let me see if I can show you something. When it comes to turning a decimal into a fraction. And the reason I actually starred some of these ones, a lot of times if I haven't taken the fraction and converted it into the decimal, I'm just working with decimals, I don't know what they're going to be in fraction. Usually when I see a decimal ending in a 5, the one that I'll multiply by as quickly as I can will be an 8. And I'm going to take this one real quick, and I might kick myself for this one, but so on my calculator, I will actually type in 0.6875. Like I said, if I didn't know that this was already 11/16, the first thing I'm going to go for, I can either go for the 16th, the smallest thing on my tape measure, or like I said, I usually quickly go for the 8. And I'm going to times that by 8. But you see there I get my 5, right? 5/8 with a remainder. So that's not really working that well. So I'm going to try this. Or it's pretty close. Or if I go 0.6875 times my 16. Oh, I get my 11. That's a little closer, right? That's what I wanted to do. Let me see that one's 0.6875 times 8. I would have bumped that up into 6/8, which brought me down to. Are you guys okay doing these conversions?
Oh yeah.
There's something I want to show you.
It's good for reinforcement.
Yeah. Because I think, is this the one I'm going to send you guys tonight? Oh, okay.
That last thing you just did made no sense.
Nope, I realize it. It's one of those things that in my head it works out, but I can't explain it. I'd have to play around with that one for a second to be able to explain what I'm doing. I want you to see this one because I'm going to send you guys this tonight. Okay. All right. So this one I'm going to send you guys this evening. All right. And I'm going to let you guys work on this one over the weekend.
Nice.
Okay. Because, hang on, let me just put this on pause. Okay. So now that we've got the 9.5 into a decimal inch, right? Here's where it gets funky. Anytime that we're changing inches into feet, feet into inches, we're going to use 12, right? Because there are 12 inches in 1 foot. Are we following so far?
Yeah.
Okay. So, because I need a decimal feet, right? I can't just write 24.9.5. I can't have 2 decimals. So I need to take this inch and turn it into feet. Think about it this way. What is 2 feet in inches? Does anybody know?
24 inches.
24 inches, right? Because we went and we multiplied 2 times 12. Right? Because for every foot, we have 12 inches. Right? So 2 feet is 24 inches, which would make 3 feet how many inches?
36.
Yep, 36 inches. Because we just multiplied 3 by 12. If we want to get a heavy inches, into feet, we do the opposite and we divide. So again, if I wanted to find 36 inches as feet, 36 divided by 12. And if you punch that into a calculator, right?
You get 3.
Yep, you get 3 feet, right? So I need to take these inches and turn them into feet. Well, I don't have a full foot, but I still have to divide inches by 12. Right? So 9.5 inches becomes 0.79166 feet. Because 9.5, that's not exactly a foot. And that's shows up here. Is that making sense?
Yeah.
Okay, because if this 9.5 reached up to 12 inches, right? 12 divided by 12 would end up with
One
whole.
feet.
Yeah, exactly. But I'm not quite at 12 inches, so I'm going to show it less than a foot.
Yeah.
Right? So now that I have that 9.5 inches into a decimal foot, all I do is throw the whole foot back onto that number. There it is there. And go ahead if you want to try typing in. Where was I going to show you? Oh, never mind. Hang on. Pretend I didn't just say something. Because I'm going to say something that's going to screw you up. Oh, who got kicked out? Oh, it's just Gary. My perpetual. Let me get back there. Okay, so take a look at some of these examples down here, guys. Following that same kind of idea, right? So we have 3 feet, 6 and 3/16 inches, right? So remember, the 3, we're just going to leave off to the side because it is going to make its way back down here. It's our whole foot. We need to turn 6 and 3/16 inches into a decimal foot. So there's where we focus on the fraction first. So turning 3/16 into a decimal of an inch. Pull the whole inch back into the equation. And then turn that decimal inch into a decimal foot by dividing it by 12. That leaves me with a decimal foot, and then I bring in my whole. How are we feeling so far?
Good.
Okay. Same thing over here. Right? 52 feet. And if you guys wanted to write it out this way, and I'm so sorry, I wish I could be able to flop this back and forth quicker than I am. Let me pull it back onto the cam. Right, so that 52 and 2 1/8. So I draw it like this. Oh, 52, 2 1/8. Can you see it now? There we go. Okay. 52. Shoot, what was the number again? Something in 1/8.
It was 3 and an 8.
Was it 3 1/8?
I'm not 100%.
Yeah, sorry, my screen kind of pooped out there. 2 1/8, my bad. 2 1/8. 52 feet, 2 1/8 of an inch. All right, that's how I would draw that or write that out. We always put these little dashes in between. So I need to turn this, woo, someone's loud. So I need to turn this into a decimal foot. So 52 is my whole foot. I need feet, so I'm just going to put that off to the side. So it's this that I'm playing with now. I'm going to start with the eighths first because that's the fraction, and I need to pull it into a decimal, right? 1 divided by 8, I believe we get our 0.125. Am I wrong there?
That sounds right.
Yeah. 0.1, it's just one that kind of stays in the mind a bit, right? So 1 divided by 8 equals 0.125 inches, right? I've just turned that into something I can put into my calculator, but I can't forget the whole inch, right? So I added on to that 2.125 inches.
That's 52.
So far, so good?
Yep.
Not plus the 52 yet.
Not yet.
Not yet, because this is still inches. I can't write 52.2.125. Right? That's a bit of a problem there. So I need to get this into a decimal foot. Right? We say decimal foot because remember, this isn't 12 inches. It's not quite a whole foot.
Right.
But this is where now I take this and divide it by 12. Right? So just for the sake of saving time, we could do this the long way, but I'm going to save time by typing it.
How did you get the 12?
Anytime that we're dealing with inches and feet.
Oh, okay, so that's the standard. Okay.
Yeah. So because there are 12 inches in 1 foot, right? So if I, again, remember, if I had have written out 24 inches, 24 inches equals 2 feet, right? If I said 24 divided by 12, go ahead and punch that in your calculator. You get 2, or 2 feet, right? 12 is the standard when dealing with feet to inches, inches to feet, right? Same as if I wanted to put feet back into this inches, instead of dividing, I now multiply it. Oh shit. Oh, what am I thinking? Sorry. Times 12. And then I'll get my 24. Think about it this way. Inches is always a bigger number. Right? And instead of saying something like, oh, okay, take this for instance. 12 feet is 144 inches. But I wouldn't tell somebody, hey, can you go and cut me 144 inches, right? Or that's 144 inches long. We would normally say it's a 12-footer.
You definitely want to address that if you got a new guy on the job and he's just starting out.
Oh.
That is true.
I had a form work instructor that he used to do that sort of crap just to sort of see the guy struggle. He'd say to a guy, hey, can you go cut me a 2-foot piece? And the guy would start to walk away and he'd go, oh, wait. No, you know what? I changed my mind. Cut me 24 inches instead. And the guy's standing there kind of going, It's the same thing. Right? But yeah, it would tend to throw off a new person going, oh, so now he wants it even bigger. But it's the same idea, right?
Now, I get confused is sometimes they divide by 12 and sometimes they multiply by 12, and now those math, it totally threw me off.
Okay. All right. Is this helping a bit or?
Yeah, oh yeah. Right now I'm clarifying. I'm trying to register and keep it in the head.
Yes.
Hopefully stay there.
Cool. That's why I also switched back to the hover cam. So it was recording the voices. You guys just would have seen, when you see the video after, you're going to see a blank table, unfortunately. So that's why I quickly pulled back over to this one. So, yeah, to finish this one off. So remember, as I was saying, we are in inches right now, right? 2 1/8 inch as this fraction or mixed fraction.
Yeah.
In a decimal inch looks like this.
Okay.
But remember, we want to turn the inches, which are usually the bigger number, into a foot.
Feet.
Yeah, into feet. So now 2, and I'm going to turn this, and I'm just going to show you guys what I'm doing with the calculator. I'm going to punch in 2.125 inches, right? And inches to feet, we divide. If I'm going feet to inches, I multiply. Okay, so inches to feet. Actually, maybe if I write that down for you.
Yeah, that will help.
Yep, inches to feet equals divide. If I want to go feet to inches, I'm going to multiply, right? Divide by 12, multiply by 12.
Okay, so this is the rule.
Yes,
I have to commit to memory.
yes, there you go.
If I don't commit to memory, those math will mess me up very big.
Yep, it took me a while, and there's occasions where if I'm doing things really quick, I'll end up screwing something up, but I usually can catch it by the number being either unexpectedly low or unexpectedly high. And that's usually when I'll go, okay, no, you messed something up there, girl. All right, so back to this one here. I want to turn this inch, decimal inch, into a decimal foot. So 2 point,
You're dividing.
yes, so 2.125 divided by 12 gives us 0.17708. I just want to double check that because I did hit a button twice. I just want to make sure I didn't mess something up. There we go. So 2.125 divided by 12 gives us 0.1770833 decimal feet. Right? So I could also then write that like this. 0. And I'm going to round it to the nearest, I'm going to round it to the nearest hundredth, or sorry, thousandth. Right? Instead of having all these. What's that?
So it's 0.177.
Yes, that's what I'm going to keep it with, right? Because, yeah, that 0 doesn't change that 7. So 0.177 decimal feet, right? Notice how up here I had my 2 little inch tickies because they were in inches. But when I divided it by 12, I turned it into a decimal foot. And this where it's important to have these little signifiers. Inch versus feet, right? Inches are 2 little tickies. Feet is the 1 little ticky. And if you're not paying attention, you could screw yourself up, right? So now that this inch has been put into a decimal foot, all I got to do now is bring in, or, oh shit, we were dealing with this one. My bad, sorry. We're bringing in the whole 52s, right?
52.1777.
You got it. 52.0177 feet. Oh my.
Oh no, just 177. There's no 0 in between.
Oh shit, thank you. I didn't notice that. Good catch. See, and that's something that could have screwed my calculations. I got it right up there. I don't know why I threw that extra 0 in there.
Yeah, because it's easy to think there's a 0 when it's behind the decimal.
Yep. But again, that would have been one of those, had I ended up doing something else, I would have went, whoa, 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 I messed something somewhere. I have to go back. All right. Now we can check this, right, by doing it like this. So if I was given this number first, I didn't see all these fractions, Someone said to me 52.177 decimal feet. What is this in inches so I can read this on a tape measure? Okay, because I can't read this on a tape measure right now. It was just...
So you multiply by 12 then.
Yeah, but I'm going to get rid of this 52 for a moment. Right? I'm going to put it off to the side for a sec. Because I'm just dealing with this 0.177 feet. Right? I need to get it into inches. Remember? Feet to inches, we multiply by 12. Right? So when I type that in my calculator, 0.177 times 12, I get 2.124. Right? It should be 5, but it's because I rounded. Right? We could have got closer, but yeah, I'll just leave it like that. 0.177 times 12, right? 2.124. So, first thing I'm going to do, if I'm using my calculator, I say, okay, I've got 2 whole inches. I'm going to throw that down for a moment because I know that one's done. And I'm going to get it out of my calculator for a moment by just doing this, minus 2. So I'm left with the fraction of an inch. All right? And this is where, I mean, I know it's going to be the 1/8 again, right? I'm going to just time this by 8ths. 0.992, that's pretty much a 1. And 8ths was the thing I used to multiply, so that'll be my denominator. If I had left in that whole number there, so 2.125 divided by 12. So if I had left this whole thing the way it is, this big number there, right? Then I would have times it by the 8. You'd get it right back there. 1.4. Yeah.
Are you using the 8 because of from the 2 and an 8 at the very beginning?
Mostly because, yeah, I already knew it was going to be 8ths. But here's that thing where you kind of said to me, I had no idea what you were talking about. When I get some of these numbers, sometimes, and someone else that might be really good with math might not have to think about it this way. But for me, I kind of take a stab sometimes. And I try and choose one of the fractions I'd find on my tape measure. Right? So I can find 8ths. I can find 16ths. Right? So that's what I usually will try and shoot for, is something I can read on a tape measure. I wouldn't see this number and want to put in something like a 5th, because I can't find that on a tape measure. Am I making any sense? Here's where I kind of knew something was going to go slightly awry, because my brain is working a little differently. Let me try another one here. Maybe this one will help you out. Let's try actually, yeah, let me try one of the ones that I have here. Let's go with this one. 11 feet, 0 inches, 3/4. All right. So I need to get this into decimal feet. Well, feet, that's my whole. I'm going to forget about that one for a moment. Okay? So I'm focusing on this. I don't even have a whole inch. It's just that 3/4, right? So I'm going to focus on that fraction first. Remember 3 divided by 4.
0.75.
Right. Inches. Now, normally, had this been another number, like, say, up here with our 2, then I would have added that 2 onto this. But I have no other full inch, right? I'm full on just 0.75. But it's still in inches. I still need to get that into feet.
So multiplied by 12.
Div-
Is it multiplied?
Divide.
Oh,
Remember
inches to
inches?
feet.
Yep,
Divide by-
inches to
oh,
feet.
sorry.
Yeah, divided by 12. Right? So 0.75 divided by 12 ends up equaling to 0.0625 feet. That kind of makes sense, right? Because it's not even anywhere close to 1 inch even. So now that I have my feet, I just pull the 11 into it. 11.0625 feet. Now again, if all I was given was this number, so if all I was given was 11.0625 feet, and I needed to figure out how to put that or use my tape measure, I'm going to get rid of the 11 real quick because I already know that's my full feet. And I'll throw that over there, my full 11 feet. Now I'm looking to find my inches. Feet to inches, that times 12. Right, so 0.0625 times 12. Right, 0.0625 times 12, and there's your 0.7, right? Normally I would say, okay, there might be a number there, and if I want to follow through, I'm going to write down 0 inches, and now I got to turn that 75 into a fraction, all right? I already know that 0.75 is 3/4.
Inches.
Pardon me?
Just did feet to inches by multiplying.
Yes, yes. Yep, multiplying is feet to inches. Right, but again, 0.75, it's kind of your common ones. I already know it's 3/4. Right, usually the most commons that people tend to remember is 1/2 is your 0.5, 1/4, 0.25, 3/4 is your 0.75. 1/8 happens to be one that I tend to remember, 0.125.
Why do you put the 0 in front of the 3/4?
Oh, we do that to signify 0 full inches.
Ah.
It's just something they taught us in school, more for the
What
confusing.
happens if you go add that 0?
You don't have to, just you have to be aware that, yeah, like you don't have a full inch.
Okay.
Yeah. The 0, honestly, guys, like I said, it's just there as sort of a placeholder because some students were getting confused. How are you guys doing with that?
So far, so good.
So far, right? If I swing back to this here. Oh, what did I get? Please don't.
I
Okay.
wish that I have these trainings before my first basic.
Mm-hmm.
It would help.
Yeah, who did you have?
Did you pass your first basic?
Catherine.
Oh.
Catherine is quite good too, yeah.
Catherine.
Did you pass your first basic?
I did, yeah.
Okay.
Just pass.
Yeah, and it sometimes comes down to the person, right? Like, I was just talking about this with my husband the other day, that you can have someone that knows their stuff inside and out, right? They can do, like, Patrick, my husband Patrick is very good with math. And it's funny because he's teaching the one of the form work classes right now, and they're going through their math right now. And he's like, holy crap, it is one thing to know your stuff, but then to have to break things down and teach it to someone else. Not everyone can do that.
Yep.
Right? Get it in a vernacular that everyone can understand.
Yeah.
Right?
That's why teachings can actually it make you understand more.
That's funny you should say that, Renee. I've said that to people before too. Usually when I see other apprentices, when they're like, oh, well, I already did it. I already know it. That's cool. Now see if you can help one of your other classmates out, because you're going to learn something different by trying to teach this to someone else. Right? You'll either discover that, crap, I don't know how to bring this down to basics, because some folks, some of this stuff just happens in their head naturally. It never came naturally to me. I had to struggle to learn how to do this math. And even now, trying to explain it to you guys, it's hard for me.
Yeah, I'm struggling too.
Yeah.
It's not occur to me naturally,
Yeah.
Very struggle.
Very hard to teach adults. I had to do it, and it's very difficult.
Yes, it really can be, right? Especially when we've got, say, multi-generational, where, we may have, us that are in, like, say, our 40s and such, we learned math a different way than some of the younger folks nowadays. Like, I've seen some of my nieces and nephews doing their math stuff, and I have no idea what's going on. I really don't. Right? So
I think the kids nowadays are doing something called coordinates or something like that.
where they do all those like weird griddings and stuff?
Yeah. What is it called?
Coordinates.
Coordinates? No, I think it's something else. I think it's called coding. It's called.
Oh, that's computers. Coding.
Oh, okay. Sorry.
Yeah, there was something where it's like, yeah, I saw one thing where to multiply, like a multiplication thing, instead of doing long division or long multiplication or adding and subtracting, they do something where they draw all these like lines horizontally, then vertically, and then, how many points intersect is, oh my God, yeah.
I wouldn't have a clue.
Yeah, I just kind of stared at the screen like, what? Yeah, it didn't make a whole lot of sense to me.
But they're not.
Do you find when you teach these type of classes, like even like the certificate classes, do you find more and more people are becoming more visual learners than studying the book and then have it in their head type people?
You know what? A lot of people in the trades tend to be kinesthetic learners. So either like visual and feel versus
How do you pronounce that? Kinesthetic?
kinesthetic. How the hell?
Kinesthetic.
Yeah, kinesthetic. Right. Essentially, touch
Touchy,
and feel.
touchy-feely.
Yeah, touchy-feely. Yes, exactly. Touchy-feely and visuals. Yeah. I'll be...
My daughter in high school,
Yep.
they never did long and division. They all have calculators.
Yeah.
I sit there and I try to do stuff with her, and I'm like, well, how do you do it? She goes, she whips out her calculator. I'm like, no, how do you do it?
Yeah.
And she's like, we don't do it this way. They just tell us to have our calculators ready.
Oh. And one day when like electronics stop working, what are they going to do?
Yeah, it's definitely a microwave culture now.
Yeah.
My daughter wasn't even taught how to do script writing. I'm teaching her now, and she's 21.
Oh, wow. So they all...
They've taken it out completely and replaced it learning computers.
Yeah.
Cursive writing is what you guys call cursive, eh?
Yeah.
Yeah, cursive writing. So they don't know how to do it. They can only print.
Yeah.
And she's an artist, and she like fine arts, but she cannot sign her name.
Yeah. Yeah. Isn't that wild, eh? So, if you want to encode a message for the younger generation, just write in cursive. Right? They won't know. It's like a different language. Okay?
There's a funny meme that's out there where it's it's like a little wizard, and it says it's like something about how to summon. It's like how to summon a demon, but it's like an N because the D and not the same. So it's got like a hole. It's got a circle, with a bunch of lemons in it.
Oh my goodness. Yeah, it's so wild. But I could go on forever about all that stuff. But yeah. So like I said, this one is going to be it might be a bit of a trickier one. This PDF I'm going to send to you guys, right? It actually kind of breaks some of that down. You can see it gives you the examples, right? So this one is going to now be our decimal feet, right? So you end up with, like I was saying, where we have the product, but now we got to bring it back into something we can read on a tape measure, right? So this one gives you the examples, gives you a few more down here, walks you through it, right? And then I think, yeah, it's got a few for you to kind of try out. All right. I'm going to send this to you guys through your emails. I'm going to actually try and do that when we get off tonight. If you guys are okay, do you mind if we cut out a little bit earlier today?
Yeah, it's fine.
Okay.
Yeah, that's fine.
Carrie, are we gonna get the recording as well?
Yes, I'm gonna get
Yeah.
that in order as well.
Nice.
Yeah. Oh, there it is, Gary. If you guys check the chat, Gary just put something in there. The little meme with the wizard. It's the writing, right? The cursive.
That's cute.